Hey, today we're going to talk about one of the more difficult concepts in organic chemistry. And we're going to talk about the idea of an isomer. And isomer has the same beginning as isotope. And remember, an isotope was an element that had the same number of protons but a different number of neutrons. So an isomer has the same chemical formula but a different, or same molecular formula but a different structural formula. And basically, I'll give you an example. Right now we have this is 1-butene, because remember the double bond is on carbon 1. But let's just say we took that double bond and we moved it from carbon 1 and we put it onto carbon 2. Now it becomes 2-butene. So it has the same formula, so when I redraw 1-butene and 2-butene, you'll notice the formulas are going to be the same. So we have 1, 2, 3, 4 carbons. And we remember by looking at our reference table that an alkene has the formula of CnH2n. So this is going to be C4H8. 1, 2, 3, 4, 5, 6, 7, 8. This one down here, 1, 2, 3, 4 carbons. And we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. C4H8. These are isomers of each other. These isomers are easy. All you got to do is move the bond around. However, let's look at something a little bit different, like, for example, butane. So butane, let me just redraw this so it'll make a little bit of sense. So I have 1, 2, 3, 4 carbons in my overall backbone. Now to make an isomer of this butane, what I could do is I could pop this one off and I got to stick it somewhere in the middle. So instead of there being a line of carbons, I'm going to have a shorter line of carbons and another carbon sticking off in the middle. This is basically how you make an isomer from a long chain of an alkane. So let's try this. Let's take this one off here, and I'm going to not move it here because it's already on this carbon. I'm not going to move it here. I got to move it on a carbon in the interior section. So I'm going to take it off of the third carbon, or second, depending on how you count it, and I'm going to put it down here. So remember, I have that H that was right there. So I'm taking this CH3, and this CH3 is called a methyl group. It's methane when it's CH4, but when I have it sticking off like a CH3, this is a methyl group. And we'll talk a little bit more about that in a second. So I'm going to take off this CH3, and I'm going to put it down here. And I'm going to re-add that H, that H that was at the bottom here, and I'm going to put it over here on the carbon. Now, when we name these, we want to figure out the longest backbone. And right now I have 1, 2, 3 carbons, 1, 2, 3 carbons, or 1, 2, 3 carbons. So either way, we know that our prefix has to be prop. And because they're all single bonds, it is going to be propane. But we got to talk about what we got here on carbon 2. So we have what is called a methyl group, like I told you, and it's sticking on the second carbon. So we put the number first, and we're going to say 2, because that's the carbon that it's on. And then we're going to write down what's sticking on carbon 2. And in this case, it is a methyl. So it is 2-methylpropane. That is how we name this compound. Now I'm going to go a little bit more complicated. And let's just say that we have a different type of compound. Okay? Now, we still have a 1, 2, 3 carbon chain, 1, 2, 3, or 1, 2, 3. I'm going to choose the carbon chain that has the double bond because we know how to name that. We call that one with the double bond propene. Now I could either have 1, 2 propene, 1, 2 propene, or 1 propene. Since this is the shortest end, we're going to count this 1, this is going to be 2, this is going to be 3. Now again, we still have a methyl group sticking off of carbon 2. But we also want to identify that this propene is after carbon 1. So it's 1 propene, but we still got to tell everybody that this methyl group is sticking off of carbon 2. So this is actually 2-methyl, 1 propene. Again, 2-methyl, 1 propene. 2-methyl, 1 propene. You're going to check your flashcards, and I've made up the flashcards for you with the isotopes, so it might be a little bit easier for you to try to figure out how they work. Also, do the practice problems. Let's do one other example. Now, we're still going to keep the propane backbone. But now we have 2 methyl groups sticking off of that middle carbon. Our backbone is still 1, 2, 3 carbons, but now we have 2 methyls. So we're going to have our backbone. It's still going to be propane, but now we got to say that we have 2 methyls, but we also have to say where they are. So this one's on carbon 2, and this one's on carbon 2. So instead of saying 2, we're going to actually write 2, 2, because it's on carbon 2 and carbon 2, and then it's going to be dimethyl 2,2-dimethyl propane. Now for any reason, if you have 3, it's going to be 3 numbers and a trie, and you're not going to find anything on the Regents that has more than 3. Now, there's going to be a little bit more challenging questions or a little bit more challenging problems in your flashcards, so I want you guys to look at your flashcards, do the practice problems, and I want you to draw the structures that I put in the practice problems. Okay? Peace.